All right, so let's look at these quick for the warm-up. Then we'll go over any of the homework questions you have. All right, so when it's in vertex form, remember, I think some of you are still a little confused, and you're allowed to ask questions during class. You guys have been so quiet. And you act like you know what, you remember, but maybe if you have a question, go ahead and ask. I'm not going to be mad at you. All right? HK is the vertex, right? The point is XY, but remember, it's still XY for 3 and 2 there, but they just use HK for the formula in vertex form. So there's our vertex form. Okay? So we have to solve for A so we can find the equation. All right, so we plug in 8 for Y. We don't know what A is. We plug in 13 for X minus H, which is 3 squared plus K, which is 2. Questions? Questions? We understand it's always X minus for the H part. So if H is a positive 3, you just put the 3 there. If H would have been a negative 3, what would happen here? It would change to what? Addition, right? So 13 minus 3 is 10. Okay, this part here is 10. What's 10 squared? 100. You with me there? Subtract the 2. And divide by 100, right? So what's our A value? What's 600ths? 3/50ths, right? So you can write 3/50ths, or you can put 0.06. When you write the equation part, you don't worry about the y and the x. You just put in your 3 and 2 for the vertex. And you substitute what you got for A in for A. Landry, you see what you were missing? Mm-hmm. Were you plugging in the right numbers though?
No, I plugged in.
Okay, so now you understand. Okay, good. That's all that matters. Try your homework. If you get it all wrong, it's okay. When we go over it, hopefully we figure out what we did wrong. Once we fix that, we've got it down, right? It's okay to make mistakes. But if you don't try, we don't know what mistakes we're making. Okay? Does that make sense, what I'm saying? Questions on that first one? Any part of that? William, did that help?
Yeah.
Okay.
So the vertex is always HK.
The vertex part are these two numbers. Yes. That's the X value of the vertex, that's the Y value of the vertex, yeah. Vince, did that help going over?
Yeah.
Okay. We good? All right, let's look at the other one. We're supposed to use intercept form. That's this one. Y equals A, then X minus P, and X minus Q. All right? The intercepts are the P and the Q. The X and the Y are the point, just like before. Okay? So the intercepts, the P and the Q. The point is still the X and Y, just like the other one. again, we have to figure out A. So over here, the y is 4, and the x is 14. All right, and one of them's 12. The other one's negative 6. Minus a negative, what do? We add, so it's actually 14 plus 6. So we get 4, and then we get A times 2 times 20. Right? What is 2 times 20? 40. So this is 40A equals 4. And divide by 40, that reduces to 1/10, doesn't it? So that's my A value. Or you could put 0.1. All right, so my equation then is y equals 1/10 for A, x minus p, and x minus q, which q, remember, was that negative 6, so it's minus a negative, that's why it's plus 6. So the information they give us, the point and the vertex, or the point and the two intercepts, help us find the A value of the equation. Once we write our equation, we leave the x's and y's alone. Does that make sense? Okay. That's basically what we did last night for homework, right? Didn't even give you any word problems, did it? So, y, there we go. What was that? Let's see here. That was one I could get rid of because I already have that. All right, I'm going to get rid of that right now. Delete this page. All right, there we go. All right, so there's the first problem. They gave us a vertex and a point. And then we just had to do what we just did for the first warm-up problem. Any questions on number 2? You guys looking at it on my paper I left you there? Questions? All right, so we should be able to do that problem by looking at the graph, or those two are the same type of problem. Any questions on 4 or 6? Okay. Then 8, another picture. You got your P and your Q, your two intercepts, and then here's your point. And then 10 and 12 were like the second one on the warm-up. Same procedure. Any questions on those? Not sure why you got it, if you made a mistake, why you made a mistake, or couldn't figure out what you did wrong. Any questions? Okay, cool. So, all right, so we did these two yesterday. Today we're going to do 3 points. Okay? And the calculator is going to do it for us. All right? So get your calculators ready. I better get mine ready too. All right, so writing equations to model data. It says when data or data have equally spaced inputs, you can analyze patterns in the differences of the outputs to determine what type of function can be used to model the data. Linear data, which we did earlier, have constant first differences. Quadratic data have constant second differences. The first and second differences of f equals x squared are shown below. All right, so All right, so this is, this f of x is x squared. What's negative 3 squared? That's how they got 9. Negative 2 squared, that's how they got 4. All right, so what they're doing here is squaring all the numbers up above, all the x's. Okay, now when they talk about first differences, they talk about the difference between these two answers. What's 9 minus 4? 5. You go from the right end towards the left end. What's 4 minus 1? 3. What's 1 minus 0? 1. What's 0 minus 1? Negative 1. What's 1 minus 4? And then 4 minus 9? Negative 5. Are those the same number? They're all different, right? If those all were the same, then it would have been a linear problem. Okay? If those were all the same number, that's what it's saying up there. That would be a linear equation there, or linear, showing us an equation of a line, basically. Okay? Now, if I do second differences, what's 5 minus 3? 2. What's 3 minus 1? 2. 1 minus a negative 1. Right? Minus a negative is like adding 1, right? So that's like 1 plus 1. Negative 1 minus a negative 3 is like negative 1 plus 3. And negative 3 minus a negative 5 is negative 3 plus 5. If the second differences are all the same number, like this, it's a quadratic. And we already knew it was quadratic, right? That's what they told us. They told us f of x is that. So they're just showing you that you can look at data and tell if it's a linear, if the data is representing a linear function, or if the data is representing a quadratic function. Okay? So we could do, if we knew it's linear, we would use our linear regression. Remember? If it's quadratic, we would use our quadratic regression. That's what we're going to use today. Okay? On our calculators. All right, so it says write an equation of the parabola that passes through the points. Okay? There's a way to do this by hand. I'm not going to make you learn the by hand way. I'm just going to show you how the calculator can do it for us. Okay? So here's what we do. How did we put data in before when we were doing linear regressions? What button did we start with? Stat. Yes, thank you, Andrew. So hit stat. And to put things in our list, we just hit enter, right? We're editing the list. So hit enter. Now, if your lists have numbers in them, remember you go up, hit clear, and then go down. Right arrow, up, clear, down. All right, if you needed to clear your list, because some of you might have something still in. Okay? So list 1 will be my x points. All right? Negative 1, 0, and 2. List 2 is my y values of my coordinates. 4, 1, 7. You guys don't have to write that out. I just wanted to show you. I just got those from the points. You guys see that, don't you? And that way I can look at them. So I'm going to go negative 1, enter, 0, enter, 2, enter. Right arrow key, 4, enter, 1, enter, 7, enter. Okay? So I got my 2 lists there. All right. How did I get to linear regression? You guys remember? What were the buttons? Anybody? Brock?
Stat, calculation.
Right. Stat, and move over 1 with your right arrow key to calculate. We did number 4 for linear, right? Well, we know it's not linear because it says it's a parabola, right? So it's quadratic. Look at number 5. What's it say? Quad. Ready. So hit 5 and then enter. All right. So what's our equation? Looking at that, what's my equation? Y equals what? 2x squared minus 1x plus 1. You guys see that? Simple, right? Doesn't show the R? Okay. If it probably hasn't been, we haven't turned your analytics on, because you got this one late, right? So we gotta go to catalog, and the D's, which is there. Turn your diagnostics on. Stat, cal, five, calculation. There it is. Anybody else have a question about your calculator? Cool. All right, so that's how we're going to do those. That's going to be easy, right? Okay. NASA can create a weightless environment by flying a plane in parabolic paths. The table shows the heights h in feet of a plane t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. All right, so we're going to put in our list 1 and list 2. These are commas here if you can't see them. All right, so put it in and go to your quadratic regression, and see what you get. So you should know what to do. Oops, I made a mistake. All right, so I got mine in. What do I do now? Stat, calc, 5. I can just hit enter. Some of you have to go down to calculate, right? So our equation is y. Oh, I should have brought that back. Let's do this first. All right, so y is negative 11 x squared plus 700 x plus 21,000. Everyone get that? Okay, so now let's answer the question. What's the height when this occurs? So what do I do? Why'd I circle 20.8? You plug that in for what? X, yeah. Okay. So, -11, 20.8 squared plus 700 times 20.8 plus 21,000. What'd you guys get? Somebody do it? 30,800. You guys agree with Mason? Those of you that also put it in? All right, so we could say 30,801, I guess. All right, that's what, feet, right? That's pretty high off the earth, huh? I don't know. It's a plane. Pretty high up in the sky. All right, questions? Pretty easy, right? That's it. Easy day. 4 problems. You can probably get them done before you leave.